Hello everyone, welcome to this video. In this video we'll be solving and looking at property 7. So here this property says if k bar is a subgroup of g bar, right? So what they are saying, you already have defined some group here as g and some other group here as g bar. Right now you are taking some subset of this g bar and calling it as k bar, right? So they are saying if we are taking k bar to be a subgroup of g bar, then its inverse image under phi is also a subgroup of g, right? So its inverse image is what? It is phi inverse of k bar. And how many elements does it contain? It contains all the elements from the group g such that phi of k is a member of k bar, correct? So basically what does it mean? It means that if you take some element here, right, and you apply the mapping phi of k onto it, it should be present within this k bar, right? This is the definition. Now in order to prove that this phi inverse k bar is also a subgroup, we'll make use of one-step subgroup test, and we'll be making use of this k bar as a subgroup of g bar. Let's see how. So in order to prove it as a subgroup, we first of all show that it is non-empty, it contains at least one element within it. So by the definition, let me copy down the definition once more here, this definition, right? So here if you see this, let me write it down here. Okay, now by this definition here you see you know phi of E is E dash, right? It is obviously present in k bar because being the identity element and it is a subgroup, it is always present. Hence this E is present in phi inverse k bar, right, by the definition. Hence this phi inverse k is non-empty in nature. This is one point. For the second point, when we wanted to prove this as subgroup, we take two elements from it and prove that k1 k2 inverse is also present here. Now if you take k1 and k2 from phi inverse k bar, what does it mean? It means that phi of k1 belongs to k bar, capital K bar, and phi of k2 belongs to capital K bar, correct? So this is there, and moreover we'll be making use of these results. So what if both phi of k1 and phi of k2 are present in k bar and k bar is given to be a subgroup of g bar, then phi of k1, phi of k2 inverse should also be present in k bar by the one-step subgroup test. Now by the properties of homomorphism, you can take this -1 power inside like this, and then you can club up these two terms like this, so they would be present in k bar, right? So by the definition, if you again look at the definition, this the brown definition written over here, so you see if you have phi of some member belonging to k bar, then this member is present in phi inverse k bar, right? So therefore in this case k1 k2 inverse belongs to phi inverse k bar by the definition. And this is what we wanted to prove here in order to prove that phi inverse k bar is a subgroup. Hence phi inverse k bar is a subgroup of the group G. So I hope you understood this property well. Well, that is it for this video. Thank you for watching.